In this video, we're going to continue looking at composite functions, but this time we're specifically looking at composite functions which involve fractions. Now, before we go on with the higher content of this video, just want to do a few reminders about a specific part of fractions here. So just a reminder that if you multiply, for example, a half by 2, we get 2 halves, which is equal to 1. If we multiply 1/3 by 3, we get 3/3, which is equal to 1. If we multiply 1/4 by 4, we get 4/4, which is equal to 1. Now, you see where this is going, but hopefully you see a pattern emerging here. Whatever my denominator is, that's what I've been multiplying by. And that's what has allowed my fraction then to simplify. And it so happens that all of these have given us 1. Now if I just generalise that now, so those were specific examples, if I generalise and I say 1 over x multiplied by x, that gives us x's, if you like, so x over x, and that is 1. And if we just try another one, for instance, if we had 1 over x plus 5, and we multiply that by x plus 5, that also gives us 1, because it's x plus 5 over x plus 5. So I thought that would be useful for you to see just before we go on with these examples. So if you need to copy that down, that's fine, as a reminder, but hopefully that should all have been straightforward for you, because you'll have known that from before. So let's have a look at some examples then. So functions f, g and h are defined by f of x equals x over 1 minus x, g of x equals 1 over x, and h of x equals 1 over 1 minus x, and all functions are defined on suitable domains. So just to reiterate, for f of x it means that x can't be equal to 1, for g of x, x can't be equal to 0, and for h of x, x can't be equal to 1. So those would be the domains for f, g and h. And the questions ask us find f of g of x and find f of h of x. So part A firstly, we're finding f of g of x. So we're taking function f, and everywhere there's an x, we are replacing it with 1 over x, because that is what the function g is. So there's everywhere there's an x, and we're replacing that with 1 over x, like so. So you can see where that substitution has taken place there. Now, we wouldn't want to leave our answer like this, because we've got fractions within a fraction, so we don't really want that. So we need to remember what we did in the first slide. In order to get rid of some of the fractions at least, we need to have a wee look at what the denominator is. So in this case, the denominator of the fractions which are sitting inside the bigger fraction, if you like, is x. So I'm going to multiply throughout by x. So the numerator multiplied by x, so that's 1 over x multiplied by x, gives me 1, because it's x over x. And then the denominator multiplied by x, so I need to take each of these separately, so 1 times x gives me this, minus 1 over x times x, so that's x over x. You can see that the numerator is 1, like I've already said, and this part gives me 1 here as well, those are the same, and this gives me x, so it's 1 over x minus 1. And we now only have one single fraction. We don't have fractions sitting within fractions, so that's a more desirable answer. Now for part B, we're finding f of h of x this time. So everywhere in f that there is an x, we are replacing it with h of x, which is 1 over 1 minus x. So it's going to look something like this, which seems a bit messy. But you can see here we had an x in the numerator, we had an x in the denominator, and we replaced it with 1 over 1 minus x. So, again, we have this scenario where there are fractions within fractions. So I'm going to multiply by the denominator of the smaller fraction. I don't mean smaller as in the actual value of the fraction. I mean smaller as in like it's written smaller just now. So I'm multiplying by 1 minus x, and that gives me 1 minus x over 1 minus x over 1 multiplied by 1 minus x minus 1 minus x over 1 minus x. Now, hopefully you can see that written down better than I've just said it. Okay. So the numerator here gives me 1. 1 multiplied by 1 minus x gives me 1 minus x. And then this fraction here gives me 1 as well, so I'm subtracting that 1. Now the numerator will stay as it is, that will still be 1. But the denominator, I've got 1 minus 1, which is 0. And then I've got this negative x. So I've got 1 over negative x, or negative 1 over x, which is my final answer. So you can take a note of this just now, and then do the assigned exercise.